Assalamualaikum warahmatullahi wabarakatuh. I bid to all our respective lecturers. So this presentation is about PBL assignment in subject PEKA 2333 Analog Electronic. My name is Nur Azri binti Nur Azman. I'm from group ACDC, which consists of 4 members. So this is the list of our group members. So my part is going to explain about the background project. So basically our project is about the class AB amplifier in PA system application. So this class AB amplifier is a combination of class A and the class B amplifier. So by to operate the loudspeaker or headphones in audio system, the performance, full power capabilities and impedance matching to output device are the key factor to measure the power amplifier, because the power amplifier is an electronic amplifier that's improve low power to high power. So basically this class AB amplifier is a modification from class B amplifier, that both devices are allowed to operate at the same time at the crossover point of the waveform, and avoiding the crossover distortion problem of the previous class B amplifier. So basically this is other methodologies in our project. The aim of the design is to get the 8 ohm of 6 watt speaker power output. So few methods have been carried out in order to obtain the design output power. So basically these are the steps in order to build the circuit. So firstly, we have to choose the type of bias for the amplifier, which is the class AB amplifier, and then we have to calculate the power input and VCC parameters of the circuit. So we have to set the resistor RL to 8 ohms, and then we have to simulate the amplifier that have been built in the circuit. After that, the output signal was observed to verify if the output power of resistor RL was approximately 6 watt. So lastly, we are discussing the simulation outcome. So that's all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ishaq Syami bin Muhammad Zamri, and I will show you the design and the simulation of the circuit of power amplifier class AB. So this is the circuit of class AB power amplifier. There is two capacitor which has been set to 10,000 nanofarad for C1 and C2. For R1 and R2, we put the value of 10 kilo ohm, and R3, which is RL, we put the value of the speaker, which is 8 ohm, and voltage input, we put the value of amplitude 9 volt and a frequency of 1 kilo ohm. For VCC, we put the value of 12 volt and negative 12 volt for Q2C. This is oscilloscope to show the wave. Okay, we start the simulation. So this is the simulation. The graph, for the yellow one is the input and the blue one is the output. So as we can see, the graph is in phase and the output has some distortion and lower from the input because of the heat loss. That's all from me. Thank you.
Hi, my name is Muwafiq and I will explain about the calculation and also for the discussion. So, as the question asks for the power in, power out, and also for the power efficiency. So, first of all, we need to find the IC. We use the formula VCC equal to IC times RL, and then we insert the value of VCC and RL, which is 12 volt and 8 ohm. So we get 1.5 amps for IC. So to get the power in, we use the formula VCC times IC divide by pi, and then we will get 5.73 watt for the power in. For the power out, we use the formula 0.25 times VCC times IC, and then we will get 4.5 watt. For the power efficiency, we just divide power out and power in and times by 100%, so we will get 78.53%. So now we will discuss about class AB power amplifier in our PA system. So basically, class AB is a combination of class A and class B power amplifier, while class A has low efficiency and low distortion, while class B has high efficiency and also high distortion at the output signal. So we combine this class A and class B power amplifier to get better output signal with higher efficiency output. And class AB has higher efficiency than class A but less than class B. In class AB circuit, diodes needs to be same exact value and placed as close as possible at the output signal. By adding a resistor into the circuit will provide stable current across the device. Alright, now we will look at the schematic diagram for our PA system. It consists of two transistors, which is NPN and PNP, and there will be two diodes X to control the biasing of the circuit, to control the biasing of the current of the circuit. And then the importance of the 10 kilo ohm resistor is to control the voltage across these two transistors. And for the last, we have the 10 microfarad capacitor to control V sign input. Okay, now for the graph from the simulation oscilloscope, for the yellow curve, that is our input signal, while the blue curve is the output signal. So the output signal is following perfectly with the input signal within the same phase. So the output signal is shown to have a lower amplitude compared to the input signal. This is due to the loss from the transistor, which have a gain AV under 1.
Assalamualaikum. My name is Sofia Nadira binti Amnuddin. I am the fourth member of Group ACDC. So today I will be discussing on the conclusion for our assignment for question 1. So for the conclusion, the model of a class AB power amplifier which follows the audio preamplifier and drives the speaker has been achieved. In this assignment, the maximum signal power to 8 ohm that should be approximately 6 watt for a frequency range of 70 Hz to 5 kHz has been obtained. Next is the design solution based on facts, ideas, learning, issues, action, solution or FILAS table has also been tabulated. Then, the design of power amplifier circuit with the BJT as the active device has been designed. The BJT component has helped greatly on amplifying signals mainly used in power amplifier system. The operation of a BJT component, which is the transistor, as the active device in the simulation with the aid of theories and concept applied has been well implemented in this assignment. And lastly, the calculation and simulation reference of the power dissipated, which is useful power being delivered to the load and the efficiency has also been achieved as well. That's all for me. Thank you for listening.